Welcome to vBlock Infrastructure Platforms Basics. My name is Todd Simmons. I'm a trainer with the VCE Global Training Practice. VCE vBlock infrastructure platforms are optimized for a wide range of virtualized solution deployments. vBlock platforms integrate best-of-breed technology from industry leaders such as Cisco, EMC, and VMware, and are backed by VCE's seamless support. Each vBlock platform is pre-built and ready for deployment. The modular design is highly scalable to meet growth needs, provide investment protection, and lower the total cost of ownership. The vBlock platform is the right foundation. It is today the best in-class infrastructure and includes equipment from trusted partners. It's built by experts. A warranty of up to 7 years helps meet your lifecycle support needs. It's extensible, providing scale-up and scale-out capabilities. It's flexible for future needs. vBlock infrastructure platforms are transforming IT today. We have a shorter time to deployment. We aim to get the vBlock out to the customer facility within 30 days. vBlock infrastructure platforms provide scalability. Customers have the ability to grow up or grow out their solution. They're based on validated best practices for virtualized applications. We provide data management solutions to reduce risk. We provide management and orchestration to help simplify operations, and every vBlock has been engineered to lower facilities costs. vBlock systems provide reduced complexity with standardized infrastructure. Our pre-integrated, pre-tested, and pre-validated units of virtualized IT infrastructure allow our customers to rapidly provision and simplify their deployments. Once the vBlock arrives on site, it's plugged directly into the customer's power and network, and it's ready to use. VCE delivers vBlock infrastructure platforms directly to the customer site within 30 to 45 days from the date of the order. Upon completing this training, you should be able to identify the 3 layers of a vBlock platform. You should be able to list the basic components of each of these 3 layers. You should be able to describe the connectivity between the 3 layers and out to customer networks. And then you should be able to identify the differences between the vBlock platforms. The topics we're going to cover include an introduction to the vBlock platforms and their components. Then we'll dive specifically into the compute, storage, and networking layers. We'll talk a little bit about virtualization and management. And then we'll wrap up by discussing the vBlock infrastructure platforms. Section 1 is an introduction to the vBlock platform layers and components. I'd like to introduce you to the compute layer of the vBlock platform. We utilize Cisco Unified Computing System chassis and blades that are powered by Intel Xeon processors. Let's take a look at the vBlock platform network layer. Here we're continuing to use Cisco components, leveraging the Cisco Nexus series of switches and Cisco Virtual Network Link services. At the vBlock platform storage layer, we leverage EMC storage utilizing both the Symmetrix vMax and the VNX block and file storage services. The vBlock platform virtualization layer leverages VMware's cloud-based operating system. Although several individual element managers can be used to configure vBlock platforms, the primary management software components used include UIM, UCS, Unisphere, and SMC. Let's review the vBlock platform compute layer. Let's take a deeper dive at the components that are used at the vBlock platform compute layer. Here, we're leveraging 3 Cisco components. We use Cisco UCS Blade servers, the Cisco Blade server chassis, and Cisco Fabric interconnects. Let's take a look at the Cisco Blade servers that are supported as part of the vBlock solution. The blade servers use Intel-based processors, and the quantity, number of cores, and speed of those processors is configurable as part of your vBlock solution. You can also select from a variety of different memory configurations with these blades. Now, each blade is going to include a mezzanine card. We also call this card the virtual interface card, and this is what connects the blade internally to the fabric extender, or the FEX. The blade servers come in two different widths. You can support half-width or full-width blades. Each of the Cisco UCS blades that we support includes a mezzanine card known as the virtual interface card. Now, in the half-width blades, you'll see one of these cards. In the full-width blades, you'll see two of these cards. Each of the cards has a dual-port 10 gigabit Ethernet connection out to the chassis. This allows you to connect directly from the blade to the fabric extender. The virtual interface card allows us to present VIFs, or virtual interfaces, directly to the ESX host. Now, we use those virtual interfaces as HBAs and network cards inside of our ESX host. The vBlock solution utilizes the Cisco UCS blade server chassis. The chassis itself has 8 blade slots. You can populate those 8 blade slots with 8 half-width blades, or 4 full-width blades, or a combination of both half-width and full-width blades. Each chassis includes 2 fabric extenders, or what's known as an FEX. The chassis itself also includes redundant power and cooling. The vBlock platform configuration has a minimum and maximum number of blade chassis that are included as part of the solution. Our smallest vBlock utilizes 2. The base configuration of the majority of vBlocks includes 4 chassis, and we have a high-end solution that can support up to a total of 40 chassis today. Each vBlock solution includes a pair of Cisco UCS fabric interconnects, or FIs. Now, the fabric interconnects are connected directly to each other to create a cluster. We assign a cluster IP address to the fabric interconnects, and then we web in to the fabric interconnect to connect to Cisco UCS Manager. Cisco UCS Manager manages the configuration of all of the blades in a Cisco UCS chassis. The configuration is stored on non-volatile memory on each one of the fabric interconnects. Now, we use the fabric extender card to create a connection directly from the blade chassis to the fabric interconnect, and then we also connect our Cisco high-performance SAN switches directly to the fabric interconnect, as well as our Cisco Nexus switches. Now, on this slide, we're looking at a Cisco UCS blade server chassis with 4 wide blade servers. You can also configure it with 8 narrow blade servers, or if you prefer, you can mix and match narrow blade and wide blade servers. Each Cisco UCS blade chassis includes 2 FEX cards, or fabric extenders. The fabric extenders have an internal connection directly to the virtual interface card on each one of the blade servers. Extending out from the fabric extender, we connect directly into the fabric interconnect. Notice in this diagram that we don't cross-cable between the fabric interconnects and the fabric extenders. Rather, each fabric extender connects directly to one fabric interconnect. From the fabric interconnect, we connect directly out to our aggregation layer, or a networking layer, and that allows us to get communication with a customer's network as well as storage. The vBlock platform's Cisco UCS design provides several benefits around availability, performance, scalability, and flexibility.